Hi, here we are in Chapter 7. So Chapter 7 is going to be about confidence intervals. And throughout the chapter, we're going to make confidence intervals for mean, proportion, and standard deviation. Here in section 7.1, it's only proportions. So suppose that somebody says, I'm 95% confident that for the whole population, the percentage is between 54 and 57%. I don't know, maybe they said, are you happy with your job? And the reporter says, well, between 54 and 57% of people say they're happy with their job. Well, because that reporter didn't go out and talk to the entire population, they can't be 100% sure that they're right. So they would say something like, I'm 95% sure it's between these two percentages. Well, that is a confidence interval. Usually we write it in decimal notation rather than percents, but it's an interval saying it's from 0.54 to 0.57. So where do these two numbers come from? So this actually goes back to about chapter 2. And way back then, we used to say scores are unusual if they're more than 2 standard deviations from the mean. So you take the mean, add on 2 standard deviations, take the mean, subtract 2 standard deviations, and that's where you get the two numbers. So we're going to do the same basic idea, except now that we've done chapter 6, we can be more accurate. Rather than just saying 2 standard deviations, we could say 1.96 standard deviations away or 2.33 standard deviations away. And basically that plus 2 standard deviations minus 2 standard deviations, that's like saying, well, the p-hat is my estimate, and then it could be off by plus or minus the error. So the p-hat is the sample percentage, so just however many successes you have divided by the total amount of people you talk to, and then the error. So here's a quick example before we start doing more advanced formula examples. So if there's an 8% chance of rain, but it could be off by 2%, then add 2%, you'd get 10%, subtract 2%, you'd get 6%, and then that's the confidence interval. All right, now down to the nuts and bolts. So the error formula is given by this. So there's the critical value, also known as z sub alpha over 2. That would be like the 1.96 or the 2.33. The p-hat is the sample percentage. Q-hat is 1 minus p-hat. And then n is the sample size. So we're going to be using table A2. And here's an example just using table A2. If you use 95% level of confidence. So the picture would look like this. In the middle is 0.95 for 95%. Then on the far right you subtract and you get 5%. So that's called alpha. Then because there's two tails, because we need to say the mean plus and the mean minus, we need the numbers on the right and on the left. So use table A2. And I'm going to look up the negative z-score first. So if you look at right here on the left, it says 0.025, and then look through the table for 0.25, it is right here. And if you look to the left, it says negative 1.9, and if you look up, it says 6. So the critical value is negative 1.96. Now you don't need to look up the other one because the graph is symmetric. The same number is on the right, but positive 1.96. Okay, now let's take a look at this example. 1,000 Americans polled, 413 say they approve of the job President Trump was doing. Create the 98% confidence interval for the proportion that believe the president is doing a good job. So first of all, 413 out of 1,000, when you divide that, it's 0.413, or in other words, 41.3% approve the job the president's doing. Then look up the critical value. So this time it's 98%. So that goes in the middle of the graph. When you subtract from 100%, you'll get 2%. And then looking up the negative z-score first, so this left tail over here is 0.01, so then find where is there 0.01. And the closest is this 0.099, so if you go to the left of that, it's negative 2.3, and then the last decimal place is a 3. So the critical value is negative 2.33. On the right, it's positive 2.33. Now use the formula for the error. So use z, which is 2.33, and then it's going to be the square root of the p hat, 0.413, and then this 0.587 comes from taking 1 minus 0.4133. That's where the 0.587 comes from. And then divide by 1,000, the error is 0.036. So now just take the p hat minus the error on the left side, the p hat plus the error on the right side, and there is the confidence interval, which is saying anywhere from 37.7% to 44.9% of Americans approve of the job that the president's doing. And I can be 98% sure that that's right. Here's another example, but this time instead of using the formula, let's use the calculator. So a survey of 104 children found 43 of them watch TV. So they watch a screen, although in my house we just call it TV, any type of screen, just before bed. Then make the 95% confidence interval. So with this, you would go to Stat, and then Tests, and then scroll down to where it says 1 proportion z interval. Then you would type in that x is 43, n is 104, and tell it the confidence level is 0.95, and then hit enter, and there's the interval. So it's saying anywhere from 31.9 to 50.8% of children watch TV or screens just before bed. So you could just write the interval like this. Then on to one last idea. What if you just had the interval? Can you find what was created to make the interval? So don't rewind the video, but if you only had this screen right here, and you only knew the answer, then what's the p hat and what's the error? So first of all, I'm just going to make a little number line. So the interval goes from 0.319 to 0.508. The p hat was in the middle. So the middle would mean just average those two numbers. Add them together and divide by 2. Then, in order to make the interval, somebody must have done plus the error on one side and minus the error on the other side. So if here you plug in what we just found, 0.413, then 0.413 plus error equals the number 0.508. And then just subtract from that little equation, just subtract 0.413 from both sides, and you get this is the error, 0.095.